Starship's 13th test flight lifted off from Starbase, Texas on Friday, July 24 at 5:51 p.m. Central Time. But getting there wasn't easy. SpaceX first tried to launch this rocket 8 days earlier, on July 16th. That attempt ended in the final second, literally at T-0, when the flight computer detected a problem with 6 of the booster's oxidizer turbopumps and automatically aborted the launch. 4 Raptor engines failed to ignite properly. SpaceX pulled 2 engines off the booster, replaced them, and started the clock again. The next attempt was pushed from Monday to Thursday, then bumped again, this time by Tropical Storm Bertha rolling through the Gulf. SpaceX also wanted better daylight visibility to track how the heat shield behaved during ascent, so they held for clearer weather. Third time was the charm. On July 24th, all 33 Raptor 3 engines on the Super Heavy booster ignited exactly as planned, and Starship's second version 3 test flight was finally underway. This mattered because it was riding on a mishap investigation from Flight 12 back in May, where the booster had lost an engine on ascent and then failed to relight enough engines to slow itself down, crashing into the Gulf. The FAA didn't clear Starship to fly again until July 13. Just 11 days before this launch. So this flight had a lot riding on it. And for the most part, it delivered. This wasn't a rocket built overnight either. The Super Heavy booster used on this flight, known as Booster 20, was shipped to SpaceX's test site back on June 5th and passed a cryogenic pressure test the next day. On July 10th, just 2 weeks before launch, it completed a full-duration static fire, igniting all 33 engines on the ground before ever leaving Texas. The Starship upper stage, Ship 40, had an even longer road. Stacking finished back in March, and it went through multiple rounds of engine testing between May and early July, including a 6-engine static fire on July 1st. By the time this vehicle actually launched, SpaceX had already fired every single one of its engines on the ground at least once. Here's the breakdown, second by second, of what this rocket actually did. At liftoff, all 33 engines on Super Heavy fired normally, something version 3 hadn't managed on its debut flight. About a minute in, the vehicle passed max Q, the point of peak aerodynamic stress. At the 2-minute 18-second mark, the booster's engines cut off, and 3 seconds later came hot staging. Starship's upper stage ignited its 6 engines while still attached, then separated cleanly. From there, the 2 vehicles went very different directions. Super Heavy attempted its boost back burn to reverse course back toward the Gulf, but the burn cut off early. Then, coming in for its landing burn, only about 10 of the 13 engines needed for splashdown successfully relit. Without enough thrust, the booster hit the water hard and was destroyed on impact. Meanwhile, the Starship upper stage was having the best flight of its life. It completed a full burn on all 6 engines and reached its planned trajectory. 16 minutes into the flight, it opened its payload bay and began deploying 20 next-generation Starlink V3 satellites, the first time Starship had ever carried operational satellites instead of dummy weight. SpaceX confirmed contact with all 20 satellites using both radio and laser links before the satellites, on their intentionally suborbital path, safely burned up in the atmosphere about 20 minutes later. At the 39-minute mark, Starship relit a single Raptor engine in space, a small but critical demonstration for any future mission that needs to maneuver in orbit. Then came re-entry. Starship punched back into the atmosphere around the 47-minute mark, using its 4 flaps to steer itself toward a splashdown zone in the Indian Ocean, executing a banking maneuver designed to mimic what a future flight landing back at Starbase would need to do. And then, just after the 1-hour, 5-minute mark, Starship relit all 3 landing engines, flipped itself upright, throttled down from 3 engines to 2 to 1, and softly touched down on the water. It did not explode.
Every previous Starship upper stage that made it this far either blew up on impact or broke apart mid-descent. This time, it didn't. SpaceX spokesperson Dan Hewitt said on the live broadcast that this was the first time they'd put an intact Starship in the water, calling it a dream scenario. And it kept going. The spacecraft didn't sink or break up. It tipped over and started floating. It kept transmitting telemetry and video from the water, letting engineers watch their own heat shield performance in near real time.
That's a big deal, because the heat shield is the single hardest unsolved problem standing between Starship and full reusability. Journalist Eric Berger at Ars Technica spoke with Dan Rasky, a former NASA researcher who spent nearly 4 decades studying heat shield materials and co-invented the material used on Crew Dragon's shield. His read on the footage? White streaks were visible along the boundaries between heat tiles, suggesting hot gas had crept through the seams during re-entry, and some tiles showed cracking. Rasky's blunt assessment was that Starship's current tile-based approach is a dead end for full and rapid reusability, echoing a problem NASA never fully solved with the Space Shuttle's own tile system decades ago.
To be fair, SpaceX isn't blind to this. Musk himself has repeatedly called the reusable heat shield the single biggest unsolved problem the company faces, saying on a podcast earlier this year that if you have to laboriously inspect tens of thousands of tiles between every flight, you'll never hit the flight rate you need. So Flight 13's data, as encouraging as it looked, also confirmed there's real work left before Starship can fly, land, refuel, and fly again in days instead of months. Still, an intact vehicle beats an exploded one. That's more heat shield data than SpaceX has ever recovered from a single flight, tile by tile, boundary by boundary.
For context on just how hard this problem is, NASA ran into the exact same wall with the Space Shuttle nearly 50 years ago. The shuttle also used thousands of ceramic tiles to protect its structure, and while they mostly worked, NASA never cracked rapid reuse. Every tile needed inspection after every flight, which made turning the shuttle around expensive and slow. Starship does have one advantage the shuttle didn't. Its steel skin can tolerate temperatures up to around 800 degrees Celsius, even where individual tiles fail, so some burn-through is survivable. But according to Charles Miller, who led NASA's transition team review of the agency's heat shield research, nobody at NASA has meaningfully invested in knee thermal protection materials for orbital reentry in roughly 3 decades. Miller's team recommended NASA launch a new research initiative on this exact problem. As of this recording, that hasn't happened.
Here's where the story gets a little strange. Because Starship 40 splashed down intact instead of the usual controlled detonation SpaceX normally triggers after landing. The vehicle just stayed there, floating in the Indian Ocean for days. Satellite imagery from Umbra Space first spotted it still floating 56 hours after splashdown. By the time Musk posted a satellite video of it on July 29th, the ship had been bobbing on the open ocean for more than 100 hours. Footage captured, oddly enough, by a Starlink satellite passing overhead. SpaceX Vice President Kiko Donchev teased the recovery effort on social media with a line comparing it to Deadliest Catch meeting Apollo 13. Musk confirmed shortly after that SpaceX is sending a recovery team to retrieve the spacecraft.
Think about the scale of what that actually involves. This is a 16-story tall, roughly 100-ton steel vehicle with around 18,000 heat shield tiles, sitting thousands of miles from Starbase Texas, near the coast of Western Australia. Multiple space reporters have speculated Australia is the most likely place SpaceX will haul it ashore for closer inspection, since bringing a saltwater-soaked heat shield all the way back to Texas, let alone refurbishing it for reflight, isn't realistic. Most likely, this ship becomes a museum piece rather than a flight vehicle again. But as a piece of hardware to study, it might be the most valuable Starship SpaceX has ever built.
Normally, none of this would even be a conversation. SpaceX typically triggers a controlled breakup of the upper stage right after splashdown, precisely so a dead rocket doesn't end up drifting through shipping lanes. This time, Ship 40 survived in good enough shape that SpaceX apparently decided recovery was worth the trouble instead.
That decision alone tells you how much confidence this flight gave the engineering team. It's also worth pointing out that the Super Heavy booster already has a track record here. SpaceX has successfully caught it with the tower's mechanical arms multiple times on earlier flights, even though this particular booster didn't manage a clean landing burn. The exact number of successful catches has actually been debated among space fans online, but the pattern is clear. Booster recovery is becoming routine. Ship recovery is the piece that's never happened, until, potentially, Flight 14.
Buried under all the splashdown drama is something that matters just as much long-term. Those 20 satellites Starship deployed were the first units of Starlink's next generation, V3. Each V3 satellite is designed to handle roughly 1 terabit per second of download speed and 160 gigabits per second of upload, reportedly around 10 times and 20 times the capacity of the older V2 mini satellites. Every one of these satellites also carries 6 laser communication links, letting data move across the constellation without needing as many ground stations. The reason Starship matters here isn't just the rocket itself, it's the payload capacity. A single Starship flight can carry roughly 40 tons of satellites, letting SpaceX add an estimated 60 terabits per second of network capacity in one launch, reportedly more than 20 times what a single Falcon 9 Starlink mission adds. If SpaceX can get Starship flying regularly, the Starlink network's growth curve looks completely different than it does today.
So what's next for Starship? Musk has already said that if the data from Flight 13 checks out, SpaceX will attempt something it's never tried before on Flight 14, catching the Starship upper stage itself with the launch tower's mechanical arms, the same chopstick catch SpaceX has already pulled off with the Super Heavy booster a few times.
But there's a catch, literally and figuratively. For that tower catch to happen, Starship first has to actually reach orbit and fly back around to Starbase, something it has never done. Every flight so far, including this one, has been intentionally suborbital. On top of that, NASA is counting on Starship to eventually demonstrate propellant transfer between 2 ships in orbit, a milestone that hasn't even been attempted yet, and one NASA needs solved for the Artemis 3 and Artemis 4 moon landings.
So yes, Flight 13 was a genuine milestone, but it also made very clear just how many firsts are still standing between where Starship is right now and the moon. And the moon is not an abstract deadline here. NASA has Starship penciled in as the lander for Artemis 3, targeting a return of astronauts to the lunar surface, with Artemis 4 following after. Both missions depend on Starship solving orbital propellant transfer, essentially fueling up one ship using another while both are in space, a maneuver that has never been attempted, let alone demonstrated. Every additional flight that doesn't test it pushes that timeline a little further to the right. That's the tension sitting underneath all the celebration this week. Genuinely great flight, still a long way to go.
If SpaceX pulls off an orbital flight and a tower catch on Flight 14, that's the moment this program stops looking experimental and starts looking operational. We'll be covering it the second it happens. If you want to stay ahead of every Starship, Tesla, and Musk universe update before anyone else, hit subscribe and turn on notifications. This is only going to get more interesting from here.